Okay, so the next part that we want to look at are derivatives of inverse functions, and there are 6 more derivatives. So these are inverse sine. So we have the derivative of the inverse sine, and that is 1 over the square root of 1 minus x squared. Okay, so there's that derivative. And then you have the derivative of the inverse tangent, which is also a fraction, but it's 1 over 1 plus x squared. No, not right now. Show you something important. Okay. All right. So these are, circle this and put a big star. These are the 2 that come up the most. Okay, so those are the 2 most important ones. These are fairly important, the inverse cosine and inverse cotangent. 23 and 24, they rarely come up, but we're just going to give you that listing just because you guys want to know what it is. Okay. But if you look at these 2, what do you notice about the similarities on this? Yeah, see how it's cosine is a negative of that, right? It's exactly the same, 1 over the square root of 1 minus x squared. And then the cotangent is identical to the tangent, except it's a negative. Right? So if you look at that pattern, you need to just memorize these 2, and then just remember the complementary function, cofunction, cosine with sine, and cotangent with tangent. They're just the negations of each other. Right? And then the other one is the inverse secant, which is this, and that has the derivative, which is 1 over x times the square root of x squared minus 1. That's that. And then the cosecant has the same pattern. It is exactly the negation of this. Okay, so let's do the examples down below here. Derivatives of the inverse trig functions. So for this one here, you have the inner function, which is the x squared. So I'll cover that up. So that derivative would just be a 2x. And then the derivative of the inverse sine, going back up here and looking at the rule, it states 1 over the square root of 1 minus, and then remember these are the inner function, so I'll just call it as something squared. Okay, so then this will be times 1 divided by the square root of 1 minus something squared. And what is my something? X squared. So then if I simplify this, I'll bring the 2x up to the numerator and then just clean up what's under the radical a bit. 1 minus, what would x squared squared be? X to the 4th. Okay, and then is there anything to simplify? Nope, and then that's it. So that will be your y prime. Okay. All right. Then we have the inverse cosine. So the inverse cosine is going to have the exact same rule as the inverse sine, except it's a negative. So I'll just do the derivative of the inner first. So the square root of x, that would be 1/2 x raised to the negative 1/2. And then the derivative of cosine is a negative 1 over the square root of 1 minus, and then it's going to be something squared. And for that one, our inner function is the square root of x. Okay, so then putting it all together, 2 can go in the denominator, and this is a square root of x in the square root of x in the denominator, but this is also a square root of x, or square root. So I can put it all under one big square root. So y prime would equal, I have a negative out in front, and then up in the numerator, I'll just have a 1. And then in the denominator, I have my 2, which is outside. And this is under the radical, so I'll just put it with this part right here. So I'll put a larger radical here. I have an x quantity, 1, and then square root of x squared just becomes x. So then this would be simplified. Now, they may multiply through or just leave it, but that would be the final answer. All right, and then our final one is this. So in part C, the inner derivative, if you just look at it the way that it is, you may just say, oh, let's use the quotient rule. Right? But remember for the quotient rule that if you have a denominator that's constant, what should you do? Yeah, you want to, well, rewrite it so that it doesn't look like this. You want to rewrite it as what? So you'll want to rewrite it as inverse tangent and rewrite it, distribute through or divide through the 3. So it'll be a 1/3 x and then a minus 1/3. That's a lot easier to take the derivative than leaving it as a quotient. All right, so why don't you make a note right here. Do not use the quotient rule. Okay, why? Because your denominator is a constant, and even if it was like a single term, you would still want to just divide through on that. Okay, what's the derivative of the inner?
1/3.
1/3. So that'll be y prime is equal to 1/3. Right, now I'm going to apply the rule for the inverse tangent, and I'm going to go back to this one. Right, I only rewrote it like this to get the inner derivative easily, but now that I'm actually doing the outer, I'm going to use this one. So the derivative of the tangent, let's go back and look at it, it is 1 over 1 plus something squared. 1 over 1 plus something squared. So then it'll be 1 over 1 plus something squared. And that something, I'm going to just put this inner function, not this one, because it'll be easier to simplify with this. So that'll become a x minus 1 all over 3. Okay, so now let's make this denominator so that it's a single fraction, right? So then this right here, I can rewrite it as just 1/3 out in front, and then I have a 1 over, and keep the 1, and just square these two separately. So up in the numerator, I'll just write it as, I'm going to square it out. So that'll be an x squared minus 2x plus 1. And then in the denominator, it'll be a 3 squared, which is just going to be a 9. Okay, and then combining 1 and this, I have to get a common denominator. So that'll give me 1/3, 1 over, so I need a 9 here, so it'll be a 9 over 9. So then it'll become a 9 plus x squared minus 2x plus 1 in the numerator of the denominator. And then in the denominator of the denominator, it'll just be a 9. And I could probably simplify this part right here. What is a third and then this combined with this 9? 3/9 in the denominator. You see that this is 3/9 in the denominator? I could do it like this. This 3 here. So it's basically a third in the denominator. What's a third in the denominator? 3 in the numerator. Okay? So then it becomes 3 up in the numerator, and then I can combine this as x squared minus 2x plus 10. And that would be your answer. I better erase this 5 so you don't think this is anything. Erase that part. That would equal my y prime. How's that? Yes?
Did you explain to me about the 3 in the numerator?
Yeah. So I have this 3, which is basically in the denominator.
Yeah.
So it's going to be, in the denominator it's 3, and then I have a 9, which is in the denominator of the denominator. So this is really a 1/9, right?
Okay.
So then that'll become a 1 over 1/3. 1/3. And what is 1 over 1/3? It's 1 times 3, so it's 3.
Okay.
Okay, so that's how you get the 3 up in the numerator. Yes, go ahead.
I still don't get what you're doing with the 3. Like, why is it?
This 3?
Yeah.
So-
Why is there a 3 in the denominator technically?
Well, let's go back to my, so I got the 1/3 from the derivative of this, right, inner? So the derivative of 1/3 x minus a third is a third. So a third is the same thing as having a 3 in the denominator. So this 3 is basically in the denominator. And then this 9, I just have that because it's a common denominator of these two. And so this one is a denominator of the denominator. So then you have a 3/9, which is a 1/3 in the denominator, which is equivalent to having a 3. Okay? All right.